All right, here we are for the third installment of Glaciers and Climate Change. So here we're going to talk a little bit about glacial retreat and then erosion as well, and deposition of the sediment that's carried inside of the glacier and then left behind when the glacier melts. So here's an example of a glacier, Bear Glacier, and you can see here about 200 years ago, the extent of the glacier, I'll use a different color, would have been out here. So what you're seeing here on this land that's at the lower part of the image was actually deposits of sediment that were laid down when the glacier was a lot bigger, hundreds of years ago, and since that time the glacier has retreated backwards. In other words, it is melting more than it is growing from annual snowfall. And so you can obviously understand how climate change would affect glacial retreat. So as the atmosphere warms, glaciers melt. As glaciers melt, they retreat back to higher elevations from where they originated. And you can see evidence of that in the picture below. You've got a couple of aerial photographs. On the left, back in 1935, the ice was obviously more extensive. You have all these glaciers feeding into the main valley here too. And then in 2013, this is all meltwater. So you can see that this particular glacier has retreated quite a lot in about 75 years worth of time. So when glaciers retreat, they deposit a lot of sediment. And the reason why there's so much sediment deposition is because glaciers are capable of a huge amount of erosion. They will erode the landscape basically in two different ways. One is a process called plucking. So these glaciers are thick and massive, and the weight of the glacier is creating a lot of pressure on the underlying topography, and as a result, that glacier has the capacity to pick up huge volumes of sediment through a process called plucking. And that sediment gets frozen in the ice and then acts almost like sandpaper on wood to abrade or polish the rocks underneath. So we see a lot of evidence of both plucking, like picking up sediment and rock, and even boulder-sized gravel, like the size of cars. And we also see evidence that that sediment combined with the weight of the ice is smoothing over or polishing the landscape underneath. Here's some evidence. Like I said in the last video, glaciers are dirty. When you think of glacial ice, you think of this beautiful blue, pristine, clear, picturesque ice. And what you can see here is that the ice is actually pretty dirty, and this is particularly true where the end of the glacier deposits sediment. So we're seeing some of that sediment deposition in this image. Erosion not only causes glaciers to carry and then transport these sediments, but it also produces kind of like a pulverized rock flour, and it creates these grooves that we call glacial striations. And both of those things are controlled obviously by the weight of the ice and also the rate of motion of the ice. The weight is dependent on the thickness. The rate is dependent on the underlying topography. So this makes perfect sense. And if we were in class, I'd do a lab where I show you that if there's a steeper topography beneath the glacier, you tend to have a faster moving glacier that has the capacity to pick up more and larger sediment. Whereas if it's a more gentle landscape underneath, the glacier's not moving as fast and it's picking up less of that sediment. So here's what glacial abrasion looks like. These are striations here on the left. And then here's a really smooth polished surface in Yosemite. So in California, at the height of the last ice age, the Sierra Nevada mountains were covered in an ice sheet. And so all of those landforms, including Half Dome and some other pretty picturesque places, are the result of the interplay between old volcanoes and kind of the roots of those volcanoes and ice, which has eroded the granite there and created these really cool and steep and smooth surfaces. Here's an example of rock powder. This is in Canada, and if you ever have an opportunity to go here, this is part of the Rocky Mountains, and it is just like a National Geographic calendar. Super pretty. You can see here that this glacier kind of has its head up in the mountains, and then you got this area here where you have sediment deposition, and that sediment is swept into this lake, which we call a moraine, Moraine lake. And the color of that lake is characteristic of glacial or alpine lakes, in that the powder or the pulverized rock, when mixed with water, makes light behave a little bit differently, and it produces this really pretty powdery blue color. Also very pretty in places like Canada and the northern extent of the Rockies and the Cascade Mountains in the Pacific Northwest and the Sierra Nevada are all these glacial landforms that are created when ice carves rock, and we get really cool topography. Glaciers tend to produce, at least alpine glaciers, valleys that have this characteristic U shape, and they tend to be straight. They can have some kind of dendritic patterns where other glaciers feed into the main valley. They create some really cool hanging valleys and weird, I guess they're called tributary glaciers. Things like this. I should pull this picture up because this is a better way to see it. So we got 3 different images here, cross sections. We've got at the top an unglaciated landscape with a river running through it. So that's kind of a mountainous area with a V-shaped valley. And then the middle image is a glacial valley, and it has more of that U shape. And in that glacial valley, you have the main glacier, and then you have these tributary glaciers. They're like branches on a tree that feed into that main glacier, which would be like the trunk. You've got some really prominent features here. If you ever go skiing in the Rockies, you might have heard of these cirques, which are circular, sounds like it, bowl-shaped depressions at kind of the head of these mountains. You might have also heard of like the Matterhorn, which is not only a ride in Disneyland or Disney World, but it's also a prominent peak that's formed where you have glaciers eroding mountains on all sides, kind of in a radial pattern, resulting in that steep peak. Then you have some areas where you get these ridges. They're called glacial arêtes, and that's where you have adjacent glacial valleys that are being carved on either side. And so you have a steep and prominent ridge line. You can also have these hanging valleys, which there's quite a few of these in Yosemite and other places in the world, where the valley glaciers are kind of truncated or cut off by the main glacier, and it creates these very beautiful, stark, and steep valleys that produce really pretty waterfalls. So here's one in Yosemite Falls. So that's essentially a lot of the landforms that are created from erosion. There are also landforms created from deposition. We'll talk about that here in a few minutes. So here's a glacial valley. I think this one looks like Scotland. And you can see that characteristic U shape of the valley. If you were up close, you would see some of those striations or polished surfaces indicating that a glacier ran through that valley. And I already talked about all of these features, so I'm going to keep going. Here's a Matterhorn. This is actually in the Alps, and it is, you guys probably know it for Disney, but it's actually in a landform in the Alps where you had glaciers carving that peak on all sides and creating a really prominent steep-sided horn. You can also get fjords, which is spelled wrong here, fjords with a J. And fjords are really cool. If you've watched Frozen 2, Arendelle is in a fjord. If you've ever visited Alaska or seen pictures and calendars of Alaska, there are tons of fjords there. Sweden and Norway and all these northern European countries have fjords, Greenland obviously as well. And so fjords are erosional features where land meets sea, and it produces these really cool kind of headlands. So here's some in Norway. So those are all products of obviously erosion, but let's also talk about deposition here. So as glaciers melt, all of that rock that they have picked up or plucked and then carried or transported in them will eventually be deposited. And there's a kind of a collective term for that. It's called glacial drift. And there's kind of different variations in size of this glacial drift that we'll talk about. So we have some that's kind of smaller and more pulverized, and then we have larger sediment that can range in size from gravel to, like I said, boulders the size of cars. So here's a type of glacial drift. This is called till. And what you might be interested to know about till is that we have a lot of this in Ohio. So the bedrock in Ohio is old. It's from the Paleozoic era. The till, which covers about 2/3 of the state, the northwest and central parts of the state, is glacial deposits that were laid down at the end of the Ice Age. So between 14 and 20,000 years ago, as ice was retreating back into Canada, all of these sediments were laid down, which makes Ohio really great for farming because those sediments are mineral rich, and when they interact with water and then become parts of the soil, that soil becomes very fertile for farming. So till is deposited when the ice melts, obviously, and drops its load of sediment. We have sediment here in Ohio that's small. We have sediment in Ohio that's huge, like the boulders that are out near Swickard in the rock circle. There's also an area behind the Ely House that has glacial erratics, and these are boulders the size of cars. So if you see these in and around central Ohio, most of the time they were deposited in situ, meaning that glaciers deposited them. Occasionally, like the rock circle in New Albany, they were put there by a construction company. But it's atypical for those things to just like show up or be deposited by something as simple as water or wind, right? Too big. So here's an example of a cool glacial erratic. Like I said, they're all over central Ohio. So if you go to any of the metro parks, you'll find things like this, just ginormous boulders randomly positioned anywhere. Other landforms that are made of till deposits are these landforms called moraines. And so in that first image where you looked at a glacier and it looked kind of dirty, it's kind of got like a black and white appearance to it. The moraine is actually made of sediment. and the sediment typically is carried in several locations. So we have what's called a medial moraine, which is where you have two glaciers that kind of meet or branch into one another. We have lateral moraines, which is at the head of the glacier or the bottom. We have some other lateral are on the sides. Terminal is at the bottom, which is where the mouth of the glacier empties out into a valley or the ocean. So here's what that looks like. These are glaciers in Alaska. And you can see here's a big prominent ridge of sediment. And then it's kind of alternating sediment, ice. We've got a medial moraine or a couple of medial moraines. We've got lateral moraines here on the sides. And then there would be a terminal moraine at the end. So here we got several valleys that are kind of feeding into the main glacier. But anyway, the point is that moraines are sediment deposits or ridges that are left behind as the glacier melts and retreats. All right. I'm going to go ahead and stop here, and I will talk to you in the 4th installment later. Okay, thanks. Bye.